I want to, Monday, you're going to have a quiz over positive exponent rules, and where you have a paper up here for your notes. Also, I collected that worksheet from yesterday if you hadn't turned it in yet. Monday, you're going to have a quiz over positive exponents. It has all the rules, product rules, quotient rules, product to a power, powers of products, power to a power, and then also quotient to a power will also be on your quiz on Monday. You do have a homework assignment today if you don't finish the worksheet, and it will be due at the beginning of class on Monday. All right, so review. It says negative 2/3 a squared b c to the fourth. Okay, so you need to take everything and raise it to the third power. The thing to be careful with, this is a negative 2/3, so it needs to be negative 2/3 inside parentheses raised to the third power. A squared to the third power would be a to the sixth, because 2 times 3 is 6. This b has a 1, so it would be b to the 1 times 3, which is 3, and 4 times 3 is 12, so it'd be c to the 12. Okay. And if you raise negative 2/3 to the third power, let's see, 2 to the third power is 8, 3 to the third power is 27. It's odd, so it'd be negative 8 over 27, a to the 6th, b to the 3rd, c to the 12th. Okay. And then this would be your final answer. And that's nothing new. That's what we covered yesterday on your assignment. Here, there's some things that I need to simplify. First, I need to do 3 times 2 times negative 1. 3 times 2 is 6, times negative 1 is negative 6. 3 plus 1 plus 2, that's 6, so a to the 6th. 1 plus 1 plus 2 is 4, so b to the 4th, and that's all raised to the 4th power. Negative 6 to the 4th power. Then you have 6 times 4 is 24, so it's a to the 24th. And 4 times 4 is 16, so b to the 16th. And then if you do negative 6 to the 4th power, and you leave it in parentheses, that means negative 6 times negative 6 times negative 6 times negative 6. So my answer is going to be positive. And I don't know off the top of my head what 6 to the 4th power is, so I'm going to use my calculator. Negative 6 to the 4th power, 1,296. So that's going to be 1,296, a to the 24th, b to the 16th. Perfect. Okay, so that's what we've been doing. And this one here is like the most complicated, the type that we've been doing. What we're doing now is quotient to a power rule. Let's say you have a fraction. Fraction means to divide. That's why they call it quotient. All you do is you take the m, or the exponent, and you raise it to the power of the top, the numerator, and you do it to the denominator. So it'd be a to the m over b to the m. Okay. Something else you need to know, which we've talked about before, is zero exponent rule. Anything to the 0 power is 1. Okay, and we've talked about that before. Number 3, 7 over 6n squared. So since this is a fraction, you're going to do 7 squared over 6n squared. And notice I put the 6n in parentheses because there's more than one thing there. Okay, now you start working it out like we did before. 7 squared is 49. Then you have to do 6 squared, which is 36, and n squared. So you have 49 over 36 n squared. Now the last thing you need to do is see if you can reduce 49 over 36. 49, its only factors are 1, 7, and 49. So we're good. So this is our answer. Number 4. Write the problem down. It is a to the third over negative 2b to the fifth, and that's all raised to the fourth power. A to the third over negative 2b to the fifth, all raised to the fourth power. All right, so since it's a fraction raised to a power, I'm going to separate them out. I'm going to do a to the third to the fourth power over negative 2b to the fifth to the fourth power. A to the third to the fourth power, that's a to the 12th. Okay. Negative 2 to the fourth power, I'm going to do negative 2, close my parentheses, raise it to the fourth power, and I get positive 16. And 5 times 4 is 20, so it's b to the 20th. And there's no numbers for me to reduce, so I'm good to go. Okay. Now that I've done 2 examples, what questions do you have for me? Over quotient to a power rule. Yes, sir.
So like if there's like a 16, like an 8, we subtract it.
Are you talking about the coefficients or the exponents?
You said since there's no numbers to subtract.
Oh, so like if there was an 8 over 16, you would have to reduce that. 8 over 16 would reduce to 1/2. So you would have to reduce it to 1/2 instead of 8 over 16.
You have to do that every time?
If you can reduce, you need to reduce. Alexis?
12 not going, like, can the 16 and 12 not have, like, the same?
These are exponents, not coefficients. The 12 goes with A and the B goes with 20. So A and B are not like terms, so you can't do anything with them. Okay. All right, number 5. Negative 4p to the fifth over 3m squared n to the third, all raised to the third power. Okay. So the first thing I'm going to do is separate it out and put each of them to the third power. So I'm going to do negative 4p to the fifth to the third power over 3m squared n to the third power. Okay. Now I'm going to use my calculator. And I'm going to type in parentheses negative 4 to the third power, and I get negative 64. And I'm going to go over here so I have more room. P to the fifth to the third power would be p to the 15th over, now I need to do 3 to the third power, which I believe is 27. And m squared to the third would be m to the 6th. N to the third would be n to the 9th. And 64 over 27, 6, 7, 8, 9, 10. The only things with 27 are 1, 3, 9, and 27, and none of those go in 64. So I'm done.
Also, you just gotta divide it.
Yeah, Alexis.
They don't have the same, like, that one's P and that one's N. Even if they did have something in common.
Yeah, because they're exponents, not coefficients. Now, if the numbers in the front were 15 and 6, then you can reduce it. That would reduce to 5 over 2. But since it's not a coefficient, it's an exponent. These exponents have nothing to do with each other. It's the bases you want to look at. So it's the P and the M that you would look at, and not the exponents.
I'm talking about like the numbers in the front. You can still do something with those, even if the letters aren't the same.
Yes, even if the letters aren't the same, yes.
Fine.
All right, let's do number 6. Quotient to a power rule. Notice you have 14a to the 5th over 7a to the 4th. I can reduce this and make it smaller before I raise it to a power. Notice 14 divided by 7. If I type in my calculator 14 over 7, I get positive 2. Positive 2. So 14 over 7 is 2. Then remember quotient rule. If you have the same base and you're dividing, you subtract the exponents. You do 5 minus 4, which is 1. So it's a to the first, or just a, and then all to the third power. So the first part's like what we've done previously. Now the next part, that's like what we did yesterday. Okay, so I do 2 to the third power, which is 8, and a to the third power, which is a to the third power. So it's 8a to the third power. So notice how at first it looked really confusing and hard, but then once I simplified it, it made it a lot easier. Okay, let's do another one before we ask questions. Negative 12 a to the 10th b squared c cubed over negative 3 a to the 5th b c. And that's all raised to the 4th power. Okay, reduce what's on the inside first. Make it easy on you. So do negative 12 divided by negative 3, and then someone tell me what you get. Positive 4. And then do a to the 10th divided by a to the 5th, and tell me what you get.
A to the 5th.
You get a to the 5th. Remember when you're doing it and they have the same base, you subtract them. So you do 10 minus 5 is 5. So you get a to the 5th. What about the b? What do I get?
You get B to the first, which is B.
And what about with my c's?
And C to the second.
And then that's all raised to the 4th power. Okay, so this first part, what we just did, that's what we've been doing. That's quotient rule. Okay. Now use your calculator and raise each of these to the 4th power. So the first one is 4 to the 4th power, and I get 256. Now when you do a to the 5th to the 4th, you do 5 times 4, which is 20, so a to the 20th. This b has a 1, so it's 1 times 4 is 4, so b to the 4th. And 2 times 4 is 8, so it's c to the 8th. And that's your answer. What questions do you have for me? Some of us that are just sitting there, is that because we've already worked it out and solved it, like way before I got through it, and because it's super easy? Or are we lost? Thumbs up if you are good. Okay. All right, let's do another example. Number 8. 7 to the 6th power over 7 to the 3rd power, all raised to the 5th power. Okay. Now these have the same base, 7 over 7. Now don't get confused here and do 7 divided by 7. A lot of people do that. But it's not 7 divided by 7. It's 7 to the 6th divided by 7 to the 3rd. So you've actually got to subtract the 6 minus 3. And 6 minus 3 is 3. So you get 7 to the 3rd on the inside. And that's raised to the 5th power. And if I do 3 to the 5th power, that's 15. So that's 7 to the 15th.
That's a lot of numbers.
Now, once you have 7 to the 15th, let's see what that is typed in our calculator. 7 to the power of 15. Wow. 4.74756,151 times 10 to the 12th. So what that means is this number had 13 digits in it.
That's a lot.
Yes, that's a huge number. We're going to leave it at 7 to the 15th power. Now, if you can write it out and it's like 256 or 1,340, then please go ahead and do that. But if you have something like this right here in your calculator and it's huge, just leave it like this. Don't worry about changing it to this big long number.
So how much is like 13?
Well, 6 digits is a million. 9 digits or 10 digits is a billion. So this would mean it had 12 zeros. So however much 12 zeros is, you have trillion.
Yes. I wish I had those.
All right, zero exponent rule. Anything to the power of 0 is 1. So if you wrote 27 to the 0 power, what's that going to equal?
1.
0.
Anything to the 0 power is 1.
But if you multiply anything by 0, it would be 0.
But I'm not multiplying it by 0. I'm raising it to the power of 0. Number 10. 4 to the power of 0 plus 7 to the power of 0.
1.
Well, 4 to the power of 0 is what?
1.
Plus, what's 7 to the power of 0?
1.
And the easiest question in math, what's 1 plus 1?
11.
2.
2.
No, 11. 1 is
Hey, I did have a teacher show me one time how 1 plus 1 was 11.
Hey, I can show you how 9 plus 10 equals 21.
Really? Number 11. 4x squared to the 0 power. What do you think that one is?
1.
Anything to the 0 power is 1, and this whole thing is getting raised to the 0 power, so it's 1.
I hope you made some easy.
See 0 equals 1.
Number 12. 4x to the 0 power squared.
Excuse me. Hold on, what? 1. Still 1.
Well, let's work it out. First, you do 4 squared. What's 4 squared?
16.
Now you do x to the power of 0 to the power of 2. Remember, you multiply 0 times 2. It's 0. What's x to the 0 power going to be? So that's 16 times 1, which is
1. 16.
16. Anything times 1 is itself. 1 is the multiplicative identity.
I was thinking of like, 0. Man, them big words hurt my head.
Yeah, so
Like, how did you even say that?
multiplicative identity. I've had a lot of
This
practice.
is a multiplicatively body.
Okay, let's do number 13.
Oh.
I almost felt myself just slip. That's a tongue. I don't know how you did that. Tongue twister.
Number 13. Negative 14b to the 5th over negative 5c, all raised to the 0 power.
It's 1.
Why?
Because it's raised to 0 now.
The whole thing is raised to the 0
Yeah, but
power.
not all these bits.
That's kind of easy though. Isn't that? That's too easy. Like,
14.
Zeros.
Negative 3 a to the 5th, b, c to the 4th, d, all raised to the 0 power.
Oh my god.
1.
1. See, I'm smart. No, you're not. She's just
Yes.
giving you easy
Hopefully,
math.
hopefully you see, like, these are some tough problems.
Oh yeah.
15.
Let me guess. 0.
32 a squared b to the 3rd c to the 5th over
Go.
negative 5 d squared f,
1.
all raised to the 0 power.
That is 1. Smart as all you. Whatever floats your boat, bro.
That's a
Never
1.
makes sleep at night, buddy.
That's a cross, Miss Goodman. That is not a 1.
And then number
Hey, I can
16.
get that over now.
Top what? It's 1. There you go.
You probably writing.
64 x to the 3rd y squared z to the 7th over negative 8 x to the 0 y squared z to the 6th, all raised to the 3rd power.
Oh, what? No, you can't do this to us.
Oh, I thought you were smart though.
Shut up.
Okay. So can I just make this one 1?
Yes.
No. You
can't
have to
do it.
reduce what's on the inside first. So first, type in your calculator 64 divided by -8.
What the heck?
It's negative.
You moved the
You get -8. Now, what do I do with my x's?
Yeah, it's factor.
Yeah, so I do 3 minus 0, which is...
Zero.
Now, what about the y's? What do I do?
They will
Subtract them.
And what's 2 minus 2?
0.
0, so
Just be y.
And then, not just y, just y would be y to the 1st. This is y to the 0. Y to the 0 and y are different. What about my z's?
it'll be
one.
just
Z1.
Okay, can I just leave it as z?
Yeah.
And then to the 3rd power.
It's normal math.
Okay, now we have to raise everything to the 3rd power. So let's do parentheses -8 to the 3rd power. I get -512. Now, what am I going to do with these 3's? You're raising a power to a power.
Few times. So.
You times them. So let's do 3 times 3. Let's get our heads up, please. Which is 9. So x to the 9th. What's 0 times 3?
3.
0.
No, 0.
0. So y to the 0. And then what's the z going to be?
Z to the 3rd power.
Z to the 3rd. Now, what do you notice about our answer?
It's not 1.
There's a variable to a 0 power.
Yeah, see this y? It's raised to the 0 power. And what's y to the 0 power?
0. 1.
Anything to the 0 power is 1. So this would be a 1. So I really wouldn't even have that y at all. I would have -512, x to the 9th, z to the 3rd.
See, I knew that was the answer. I was just seeing something.
I knew it was the answer when you first wrote it down.
You shut up, Scott.
All right, what questions do you have for me?
Can we have like the one that gives like one answer?
Like 1 for an answer?
Yeah, on that test.
Anything to the
On
kindergarten.
the test, there's probably one. I know, I think I remember there being 1 on there.
Can there be like the whole test on there?
No. Let's test this a little bit.
All right, for your
You're just
worksheet.
playing.
Let's get our heads up, please. Parker.
Oh my God.
Hey,
He's like, oh no, I thought he was
All right, so you have a worksheet. There are 12 problems. You are to work these out using your notes.
only 4?
If you don't finish, it will be homework due at the beginning of class on Monday, and you have a quiz on Monday. Also, after everyone's finished with their quiz on Monday, we will have we will start our notes on negative exponents. And then your test for negative exponents will be on Friday. And then your final will be the following week. I believe it's Wednesday of the last week of school. So Monday and Tuesday we'll be reviewing. Now, if you have a 90% or higher for the semester, the final will be optional. And you will not have to take the final if you have a 90 or above for the semester.
Say less.
Now, if you decide you want to take the final, you have to take the grade. You can't take the final and then say, oh no, I don't want to do it. So if you have a 90% or above for the semester and you want to make the final and you do not want to take the final, you will not have to take the final.
So are we all gonna have our finals on like a class? Wait,
I-
knowing my luck, I'll have an 89.
Wait, why don't